Chapter 13 Sound. How do you come to know that period is over in your school? You come to know easily that someone is at your door when he knocks or you hear the sound of the doorbell. Most of the time, you can make out that someone is approaching you by just hearing the footsteps. You might have played a game called hide and seek. In this game, a person is blindfolded and has to catch the remaining players. How is the blindfolded person able to guess which player is closer to her? Sound plays an important role in our lives. It helps us to communicate with one another. We hear a variety of sounds in our surroundings. Make a list of sounds you hear in your surroundings. In the music room of your school, you hear the sound produced by musical instruments like flute, tabla, harmonium, etc. How is sound produced? How does it travel from one place to another? How do you hear sound? Why are some sounds louder than others? We shall discuss such questions in this chapter. Sound is produced by a vibrating body. Touch the school bell when not in use. What do you feel? Again touch it when producing sound. Can you feel it vibrating? Activity 13.1. Take a metal plate or a pan. Hang it at a convenient place in such a way that it does not touch any wall. Now strike it with a stick. Do you hear a sound? Touch the plate or pan gently with your finger. Do you feel the vibrations? Again strike the plate with the stick and hold it tightly with your hands immediately after striking. Do you still hear the sound? Touch the plate after it stops producing sound. Can you feel the vibrations now? Activity 13.2. Take a rubber band, put it around the longer side of a pencil box. Insert two pencils between the box and the stretched rubber. Now plug the rubber band somewhere in the middle. Do you hear any sound? Does the band vibrate? As you learnt in class 7, the to and fro or back and forth motion of an object is called vibration. When a tightly stretched band is plugged, it vibrates and produces sound. When it stops vibrating, it does not produce any sound. Activity 13.3. Take a metal dish, pour water in it. Strike it as it is edged with a spoon. Do you hear any sound? Again strike the dish and then touch it. Can you feel the dish vibrating? Strike the dish again. Look at the surface of water. Do you see any waves there? Now hold the dish. What changes do you observe on the surface of water? Can you explain the changes? Is there a hint to connect sound with the vibrations of a body? We see that a vibrating object produces sound. In some cases, the vibrations are easily visible to us, but in most cases, their amplitude is so small that we cannot see them. However, we can feel them. Activity 13.4. Take a hollow coconut shell and make a musical instrument ektara. You can also make it with the help of an earthen pot. Play this instrument and identify its vibrating part. Make a list of familiar musical instruments and identify their vibrating parts. A few examples are given in table 13.1. Complete rest of the table. Many of you might have seen the manjira cymbals, the ghantam and the nut, mud pots, and the kartal. These musical instruments are commonly used in many parts of our country. These instruments are simply beaten or struck. Can you name a few other musical instruments of this type? You too can make a musical instrument. Activity 13.5. Take 6 to 8 bowls or tumblers, fill them with water up to different levels, increasing gradually from one end to the other. Now take a pencil and strike the bowls gently. Strike all of them in successions. You will hear pleasant sounds. This is your Jal Tarang. 13.2. Sound produced by humans. Speak loudly for a while or sing a song or buzz like a bee. Put your hand on your throat as shown in figure. 13.8. Do you feel any vibrations? In humans, the sound is produced by the voice box or the larynx. Put your fingers on the throat and find a hard bump that seems to move when you swallow. This part of the body is known as the voice box. It is at the upper end of the windpipe. Two vocal cords are stretched across the voice box or larynx in such a way that it leaves a narrow slit between them for a passage of air. When the lungs force air through the slit, the vocal cords vibrate, producing sound. Muscles attached to the vocal cord can make the cords tight or loose. When the vocal cords are tight and thin, the type or quality of voice is different from that when they are loose and thick. Let us see how the vocal cords function. Activity 13.6. Take two rubber strips of the same size. Place these two pieces one above the other and stretch them tight. Now blow the air through the gap between them. As the air blows through the stretched rubber strips, a sound is produced. You can also take a piece of paper with a narrow slit and hold it between your fingers, as shown in figure. Now blow through the slit and listen to the sound. Our vocal cords produce sound in a similar manner. 13.3. Sound needs a medium for propagation. When you call up your friend who is standing at a distance, your friend is able to hear your voice. How does the sound propagate or travel to her? Activity 13.7. Take a metal or glass tumbler. Make sure that it is dry. Place a cell phone in it. Remember that the cell phone must not be kept in water. Ask your friend to give a ring on this cell phone from another cell phone. Listen to the ring carefully. Now surround the rim of the tumbler with your hands. Put your mouth on the opening between your hands. Indicate your friend to give a ring again. Listen to the ring while sucking air from the tumbler. Does the sound become fainter as you suck air? Remove the tumbler from your mouth. Does the sound become loud again? Can you think of explanation? Is it possible that the decreasing amount of air in the tumbler had something to do with decreasing loudness of the ring? Indeed, if you had been able to suck all the air in the tumbler, you will not listen any sound. Actually, sound needs a medium to travel. When air has been removed completely from a vessel, it is said that there is a vacuum in the vessel. The sound cannot travel through a vacuum. Does sound travel in liquids? Let us find out. Activity 13.8. Take a bucket or a bathtub. Fill it with a clean water. Take a small bell in one hand. Shake this bell inside the water to produce sound. Make sure that the bell does not touch the body of the bucket or the tub. Place your ear gently on the water surface. Be careful, the water should not enter in your ear. Can you hear the sound of the bell? Does it indicate that sound can travel through liquids? Let us find out if sound can travel through solid also. Activity 13.9. Take a meter scale or a long metal rod and hold its one end to your ear. Ask your friend to gently scratch or tap at the other end of the scale. Can you hear the sound of the scratching? Ask your friends around you if they were able to hear the same sound. You can also perform the above activity by placing your ear at the one end of long wooden or metallic table and asking your friend to gently scratch the other end of the table. We find that sound can travel through wood or metal. In fact, sound can travel through any solid. You can perform interesting activities to show that sound can also travel through strings. Have you ever made a toy telephone? Can you say that sound can travel through strings? We have learned so far that vibrating objects produce sound and it is carried in all directions in a medium. The medium could be a gas, a liquid, or a solid. How do we hear it? The eardrum is like a stretched rubber sheet. Sound vibration make a eardrum vibrate. The eardrum sends vibrations to the inner ear. From there, the signal goes to the brain. That is how we hear. We must never put a sharp, pointed or hard thing into our ear. It can damage the eardrum. The damaged eardrum can impair hearing. 13.5. Amplitude, time period and frequency of a vibration. We have learned that the to and fro motion of an object is known as vibration. This motion is also called oscillatory motion. Hear the sound produced. Now bang the spoon on the tumbler and hear the sound produced again. Is the sound louder when the tumbler is struck hard? Now suspend a small thermocol ball touching the rim of the tumbler. Vibrate the tumbler by striking it. See how far the ball is displaced. The displacement of the ball is a measure of the amplitude of vibration of the tumbler. Now strike the tumbler gently and then a little harder. Compare the amplitudes of vibrations of the tumbler in the two cases. In which case is the amplitude larger? The loudness of sound depends on its amplitude. When the amplitude of vibration is large, the sound produced is loud. When the amplitude is small, the sound produced is feeble. Compare the sound of a baby with that of an adult. Is there any difference? Even if two sounds are equally loud, they differ in some way. Let us see how. I wonder why many voice is different from that of many teacher. The frequency determines the shrillness or pitch of a sound. If the frequency of vibration is higher, we say that the sound is shrill and has a higher pitch. If the frequency of vibration is lower, we say that the sound has a lower pitch. For example, a drum vibrates with a low frequency. Therefore, it produces a low-pitched sound. On the other hand, a whistle has a high frequency and therefore produces a sound of higher pitch. A bird makes a high-pitched sound, whereas a lion makes a low-pitched roar. However, the roar of a lion is very loud, while the sound of a bird is quite feeble. Every day you hear the voices of children and adults. Do you find any differences in their voices? Can you say that the frequency of the voice of a child is higher than that of an adult? Usually, the voice of woman has a higher frequency than that of a man. 13.6. Audible and inaudible sounds. We know that we need a vibrating body for the production of sound. Can we hear the sound of all vibrating bodies? The fact is that sounds of frequencies less than about 20 vibrations per second, 20 Hz, cannot be detected by the human ear. Such sounds are called inaudible. In the higher side, sounds of frequencies higher than about 20,000 vibrations per second, 20 kHz, are also not audible to the human ear. Thus, for human ear, the range of audible frequencies is roughly from 20 to 20,000 Hz. 13.7. Noise and music. We hear different types of sounds around us. Is the sound always pleasing? Does a sound sometimes cause discomfort to you? Some sounds are pleasant to the ear, whereas some are not. Suppose construction work is going in your neighborhood. Are the sound coming from the construction site pleasing? Do you enjoy the sounds produced by horns of buses and trucks? Such unpleasant sounds are called noise. In a classroom, if all the students speak together, what would the sound produced be called? On the other hand, you enjoy sounds from musical instrument. Musical sounds is one which is pleasing to the ear. Sound produced by a harmonium is a musical sound. The string of a sitar also gives out a musical sound. But if a musical sound becomes too loud, would it remain a melodious? 13.8. Noise pollution. You already know about air pollution. Presence of unwanted gases and particles in air is called air pollution. Similarly, presence of excessive or unwanted sounds in the environment is called noise pollution. Can you list some sources of noise pollution? Major causes of noise pollution are sounds of vehicles, explosions, including bursting of crackers, machines, loudspeakers, etc. What sources in the home may lead to noise? Television and transistor radio at high volumes, some kitchen appliances, desert coolers, air conditioners all contribute to noise pollution. What are the harms of noise pollution? Do you know that presence of excessive noise in the surroundings may cause many health-related problems? Lack of sleep, hypertension, high blood pressure, anxiety, and many more health disorders may be caused by noise pollution. A person who is exposed to a loud sound continuously may get temporary or even permanent impairment of hearing. Measures to limit noise pollution. To control noise, we must control the sources of noise. How can this be achieved? For this, silencing devices must be installed in aircraft, engines, transport vehicles, industrial machines, and home appliances. How can the noise pollution be controlled in a residential area? All noisy operations must be conducted away from any residential area. Noise producing industries should be set up away from such areas. Use of automobile horns should be minimized. TV and music systems should be run at low volumes. Trees must be planted along the roads and around buildings to cut down on the sounds reaching the residents, thus reducing the harmful effects of noise pollution.